Hello, fellow chemists. In this video, we're going to be taking a look at valence electrons and why they are so important to understand in atoms. This is labeled as an intermediate level video because it assumes that you have a basic understanding of electron arrangements in atoms. If you need a review of that topic, I will put a link in the upper right-hand corner. So let's get started. Valence electrons, what are they? They are the electrons that are furthest away from the nucleus. They're the electrons that are highest in energy. Why are they high in energy? Well, you can think of each electron as having a little rubber band tied around it, and then the other end of that rubber band is tied around the protons in the nucleus. Well, electrons that are close to the nucleus, the rubber band is going to be loose. So they don't have to exert much energy to exist close to the nucleus. Remember, electrons are negatively charged, protons are positively charged, so they're attracted to each other. They want to be close to each other. So electrons that are in the lower energy levels are happy electrons. They're low energy. Then as you get a little bit further out and you look at the electrons that are in the medium range, so their rubber bands would be a little bit tighter. And those electrons would be less happy because they're further away from the protons. But then as you get all the way out into the outer areas, the electrons furthest away from the nucleus, their rubber bands would be as tight as possible because they're far away from the protons. And they would be the sad electrons because they have to exert a lot of energy to exist so far away from the protons. Those electrons that are far away, that are in the highest energy levels, they are called the valence electrons. And they are the electrons that are going to be involved in bonding with other atoms. Because when those electrons, those valence electrons, bond with another atom, it will lower their overall energy. So just as a little review of what we've seen so far, the center of the atom I have drawn here is this little yellow circle. That's the nucleus. The first energy level here can hold a maximum of 2 electrons, and those are low energy electrons. We call this the first energy level or the first shell. The second energy level or the second shell is a little bit further away from the nucleus. Those electrons are a little bit higher in energy, and the second shell can hold 8 electrons total. And the third energy level is drawn out here. They would have higher energy electrons, and they can hold, remember, they can hold up to 18 electrons, but we're not going to look any further than 8. And if I were to draw a fourth energy level out here, they would be even higher energy electrons, if any electrons existed in that level. That would be the fourth shell, and we're only going to look at up to the first 2 electrons in that energy level. So what we're going to do today is we're going to draw some models of atoms and then use those models of atoms to write what's called an electron arrangement, which lets us know which electrons are in which shells and tells us their relative energies, lets us identify how many valence electrons there are in that particular atom, and then also lets us look at overall electrons and highest energy electrons. So let's get started with drawing a couple models of atoms, and we'll start off by looking at nitrogen. Now for these atoms, I'm going to represent the nucleus by just putting the symbol for the element. So nitrogen here, that's going to represent the nucleus. And then we'll take a look at the electron clouds going around nitrogen. As you can see in the periodic table, nitrogen is in the second period, so that means it's only going to have 2 energy levels. So I'll draw 2 circles here. So you have your first energy level, your second energy level. And if we also take a look at nitrogen, it has 7 protons. So if it's a neutral nitrogen, that means it's also going to have 7 electrons. So nitrogen will have 7 electrons. And let's place those electrons in the proper energy shells or energy levels. Well, the first 2 electrons will go in the first energy level, because the first energy level can only hold 2 electrons. Second energy level can hold up to 8 electrons, but nitrogen has 5 electrons left. So we'll put 1, 2, 3, 4, 5. And that gives us a total of 7 electrons. So 1, 2, 3, 4, 5, 6, 7. So we've drawn all the electrons in nitrogen, and we've drawn them in their respective shells. The first shell has 2, and the second energy level or second shell has 5. The electrons in the outermost energy level are the valence electrons. So we can see that nitrogen has 1, 2, 3, 4, 5 valence electrons. So nitrogen has 7 total electrons, but has 5 valence electrons. And it's going to be these valence electrons that will potentially be involved in bonding. Now, how to draw the electron arrangement, we'll just represent that by EA. You just put a number for each number of how many electrons are in each energy level. So the first energy level has 2 electrons, so that'll be a 2, and we put a comma. The second energy level has 5 electrons, so we put a 5. So remember, in the lower energy levels, these are low energy electrons. Then as you get further away, these are high energy electrons. So we can see here the electron arrangement kind of tells us this is the first shell electrons, and these are the second shell electrons. These are the low energy electrons, and these are the high energy electrons. And then we can also see that these 5 electrons are the valence electrons. So the electron arrangement tells us a lot of things. It tells us the energy levels that each of the electrons are in, gives us their relative energies, and it also lets us know how many valence electrons there are for that particular atom. So let's take a look at another example of drawing a model of an atom and then using that to determine its electron arrangements, its relative electron energies, and its valence electrons. We'll take a look at the element phosphorus. This is a little bit larger of an element, so we'll put a P there to represent the nucleus. Phosphorus is element 15 on the periodic table. Phosphorus is in period 3, so that means it's going to have 3 energy levels that we need to draw. Here's the first energy level, the second energy level, or the second shell, and then the third energy level, or the third shell. Now, phosphorus has a total of 15 electrons. Phosphorus has 15 electrons. So let's begin placing them in the atom. Remember, the first shell can only hold 2, so we'll put 2 there. The second shell can hold 8, so we'll put 8 in there. And once we get done putting 8 in there, we have a total of 10 electrons. 2 in the first shell, 8 in the second. We have 5 left, so we'll put those last 5 in the third shell. And we can see now that we have phosphorus mapped out with 15 electrons. These are the low energy electrons here. These are the mid energy electrons in the second shell. And then in the third shell, these are the high energy electrons. And the electrons that are in the furthermost shell, the highest energy electrons, those are the valence electrons. So phosphorus has 1, 2, 3, 4, 5 valence electrons. And the way that we would show that if we did an electron arrangement for phosphorus is we would put a 2 because there's 2 electrons in the first energy level. Put a comma, then we would put an 8 because there's 8 electrons in the second energy level. Then we would put a comma, and then we would put a 1, 2, 3, 4 because there are 1, 2, 3, 4, 5. Sorry, put a 5 because there's 5 electrons in the third energy level. So remember, this is the first shell. This is the second shell electrons. This is the third shell electrons. These electrons here are low energy. These electrons here are mid-level energy, but not high enough to want to react. And then these electrons here, since they're furthest away from the nucleus, are the high energy electrons. These are the ones that are going to want to react with other atoms. And those high energy electrons, these are also called our valence electrons. So you can see that by writing a model of an atom and then writing its electron arrangement, the electron arrangement tells us which energy levels each of the atoms are in, tells us their relative energies, and then also lets us know which electrons are valence electrons, which are the electrons that are going to want to bond or interact with other atoms. That is it for this lesson. I hope you learned something. If you did, make sure to like and subscribe, and I will see you in the next video.